Now that we've studied the power rule and the product rule, we're ready to tackle the quotient rule. In other words, we're ready to find a general form that will enable us to differentiate u of x over v of x. Of course, v of x not equaling to 0. Now, of course, to find a formula to differentiate this quotient, we need to go back to the definition of a derivative. And remember, the definition of f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Now, of course, in this particular problem, we've defined f of x to be u of x over v of x, this quotient of functions. So I'll just do a little bit of substitution here. We have the limit as h goes to 0 of u of x plus h over v of x plus h minus u of x over v of x all over h. So all we did was we still have the definition of a derivative, only we've substituted in the quotient in place of the function. Now, the next step. I want to work with this complex fraction so that I get a fraction that's not complex. In other words, I want just one numerator and one denominator. Now, the way we do that is we multiply by the least common denominator. In other words, I'm going to multiply the top and the bottom by v of x times v of x plus h. Now, let's see what happens when we do that. What happens when we do that is the following. Notice when I multiply this first term by v of x times v of x plus h, the v of x plus h cancels, and I just get u of x plus h times v of x. Likewise, when I multiply u of x over v of x by v of x times v of x plus h, the v of x cancels, and I get u of x times v of x plus h. And then, of course, in the bottom we have the entire product. H times v of x plus h. Okay, now that we've got it a little bit simplified, we're ready to start trying to manipulate this difference quotient to come up with a general way of finding the derivative of a quotient. Here's the trick we're going to use. I'm going to add and subtract the following. U of x times v of x. If I do that to the numerator, I'm within my rights because I'm not really adding anything, because I'm adding it and subtracting it as though I'm adding 0. However, it's going to enable me to do something interesting here. So let's see what we have. I've got the limit as h goes to 0. Just rewriting u of x plus h times v of x plus u of x v of x minus u of x v of x. Okay, so I just added it and subtracted it. Nothing wrong with that. Now, I've got minus u of x v of x plus h. All that over, of course, the denominator. Now, the reason I did that is because I want to do some regrouping here. Here's what I'm going to do. I'm going to take this first part, u of x plus h v of x, and I'm going to group it with this minus u of x v of x. Likewise, I'm going to take this u of x plus u of x v of x and group it with this u of x v of x plus h. So here we go. Here's the first thing. The limit as h goes to 0 of u of x plus h v of x minus u of x v of x all over this denominator. Okay. Now, notice what I have left. I have this, the yellow part. I have the minus u of x v of x plus h, and this positive over here, u of x v of x. Now, I'm going to factor out a negative, and you'll see why in just a minute, because it's going to work out for us to be in a nice, convenient form. So I'm going to factor out this negative, put a negative there, and then go ahead and rewrite this. The limit as h goes to 0. Now notice, I put this positive part first because remember I factored out the negative. So here we go, u of x v of x plus h. Minus now, because I factored out the negative, u of x v of x. And once again, all over the denominator. Okay, now that I've done that, I'm going to utilize a property of limits that says a limit of a product is equal to a product of the limits. So what I'm going to do, I'm going to factor out from this first one the v of x and give it its own limit here on the outside. So I've got the limit as h goes to 0 of v of x times the limit as h goes to 0 of u of x plus h minus u of x all over h v of x v of x plus h. Okay, so nothing wrong with that. Now I'll do the same thing to the other part of this. Except this time, instead of factoring out the v of x, I'm going to factor out the u of x. And notice what we get. We get something that's starting to look a little bit familiar. Okay. Notice we've got v of x plus h minus v of x over h, but not just h, it's h times v of x plus h. Now I want to do this. I'm going to factor out from each of these denominators the v of x times the v of x plus h. I'm just going to factor that out. And notice, here's what I get. Notice, for this first term, I get the limit as h goes to 0 of this. V of x over v of x times v of x plus h. And then I've got what's left. The limit as h goes to 0 of u of x plus h minus u of x all over h. Now that really looks familiar. That looks like the derivative. Now let's do the same thing to this other part. We have the limit as h goes to 0 of u of x over v of x plus h, and then the limit of v of x plus h minus v of x over h. Now, let's just take a look at this a minute. Notice that if we look at this first limit, the limit as h goes to 0 gives us this. First of all, the limit of the top, v of x, well, that doesn't have an h in it, so that's just going to be v of x. The bottom, however, is going to be v of x. If h goes to 0, this is just v of x squared. So this is just v of x squared. And then for this second term, well, the limit as h goes to 0 of u of x plus h minus u of x over h, that by definition is u prime. That's the derivative of u. So now notice what we have. We have v of x over v of x squared times u prime of x. Now let's look at the second part. Minus, over here we have u of x up top, all over, once again, v of x squared. Because the limit of u of x as h goes to 0 is just u of x, the limit of v of x times v of x plus h as h goes to 0 is v of x squared. Now, here we have the limit as h goes to 0 of v of x plus h minus v of x over h. That, by definition, is the derivative of v. Now, look what we have here. We have a common denominator of v of x squared. V of x squared. So look what we have now. Let's put this together. Put it all over one denominator. Looks like we have this. We have the derivative of the top times the bottom. That's this over here, minus the derivative of the bottom times the top. All over the bottom squared. Now, look at this. So we're saying this. The derivative of u of x over v of x is this. The derivative of u of x times v of x minus v of x, the derivative of v of x times u of x all over v of x squared. In other words, the derivative of the top times the bottom minus the derivative of the bottom times the top. Now, let's look at an example. So here's what we have. We have f of x equals u of x over v of x. And we're told that the quotient rule is this. The derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. Now, let's see how we would apply that. Let's suppose that we have a function. Let's say 2x plus 3 over 5x plus 1. So there's our function. Now, notice that, of course, we have 2x plus 3 would be like u of x, and then 5x plus 1 would be like v of x. Now, let's apply the quotient rule. F prime of x. We're going to get the derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. And I guess I wrote this incorrectly. this would be not 2x plus 1, but plus 3. Okay? So this is the top. This is the bottom. And then we've got the derivative of the top. And then, of course, the derivative of the bottom. I think that's everything. Okay. So notice the derivative of the top times the bottom. And then the derivative of the bottom times the top, all over the bottom squared. Okay. Now, the only thing that's left to do is simplify. Now, in general, we're not going to multiply out this bottom. In general, the simplification is going to involve doing something with the numerator. You can multiply out the denominator, but in many of these problems, it's not going to help you. More often than not, you're better off leaving the denominator just as something squared. So here we go. Let's go ahead and multiply out the top. Just using the law of distributivity, we get 10x plus 2 minus 10x minus 15. Now, one thing, remember, when you're dealing with this quotient rule, the fact that it has a negative in it, the fact that you're subtracting, that tells you have to be careful. Always when you see a minus sign, it means proceed with caution. Notice you have to be careful because there's potential to make an error when you're multiplying through by this 5 that you might, for example, call this a 15 instead of a negative 15. But it's clearly a negative times a positive. So just be careful. Now, notice this positive 10x, negative 10x, cancel. Negative 15 and positive 2, that's negative 13. All over the bottom, which is 5x plus 1 squared. And there you have it. There's the derivative of this quotient using the quotient rule.